Hello students, welcome to BioWise with Achal, and today we are going to revise the basic concepts of chemistry. Now this is the time for the examination, the first term examination in all the schools. So at least the basic need to be cleared before your exams. So let us start quickly with the basic concepts of chemistry. I will be covering certain topics like atoms, molecules, ions, atomicity, valency, making formula, making reactions, types of reactions, balancing of equations. So stay tuned till the end of the video. Now first of all, when we talk about the basic concepts of chemistry, we need to know what an atom is, what a molecule is, and what are ions, right? Atom, molecules and ions. Okay. Now when I talk about atoms, atoms are basically the smallest unit of a substance, and it may or may not exist independently, right? For example, H is an atom of hydrogen, O is an atom of oxygen, N is an atom of nitrogen, correct? These alphabets which are used to write the atoms are basically the symbols of the element. Symbols of the element can be the first letter of the English name of the element or the Latin name of the element, or it can be the first two letters of the name. For example, if I have HON, I also have Cu. Cu is for copper, cuprum, Fe iron, ferrum, Pb lead, plumbum, Hg mercury, that is hydrocarbon, aurum, that is gold, right? So we have different ways in which we write the symbols, and these all represents the atom of an element. Is that clear? Atoms are electrically neutral. Why neutral? We will be talking about when we talk about the atomic structure. Okay. Next is the molecule. Molecules are capable of independent existence. Like hydrogen cannot exist as H, it exists as H2, O2, N2, ozone O3, phosphorus P4, sulfur S8, right? Similarly, molecules of compounds like CO2, H2O, H2CO3, these are the formula of the molecules. The molecules exist independently. Like whenever a reaction happens and hydrogen gas is released, it is released as H2, not H. Understood? Like for example, if a metal is added to an acid, hydrogen gas is released. You cannot write H over there. You have to write H2. Similarly, when we talk about ions, ions are charged particles, right? Ions are charged particles. Like atoms and molecules, they have zero charge. Okay, they have zero charge. But ions have charge. So based on the type of charge they have, there are two types of ions. One is cation and one is anion. Now cations, you can see here cat has got pause, so cations are positive charged and anions are negatively charged. Is that understood? So based on the cations and anions, you form the compounds. Compounds are electrically neutral because the amount of charge on the cation should be equivalent to the amount of charge on the anion. Now what did I say? When you talk about a formula, okay, when you talk about a formula, for example NaCl, now you tell me that which one is a cation and which one is an anion, and how will you identify that? Cations means positively charged particles. How an atom can be a positively charged particle? how an atom can be a negatively charged particle, how can a group of atom acquire a charge. Is that clear? So, we need to know all this to understand this concept. Basic concept is, the first one is generally a cation and the second one is an anion. And since we know that cation and anion cannot be written without the charge, so if my question is identify the cation, it is Na plus, you know the valencies, right? We will revise it. And anion here is Cl minus. If you have to name it, it is sodium ion, and you have to name it, it is chloride ion. Is that clear? So, when until unless they ask you the symbol or the formula, try to write the full names. Is that clear? This is about the atoms, molecules and ions. So, let me clear the board first. Now, next we are going to talk about the atomicity. Now, before I go to the atomic structure, first you should know that how atoms forms the molecules. So, when we talk about atomicity, we are talking about the molecule. How many atoms are present in a molecule? Is that clear? So, when I say atomicity, right, these words, atomicity and valency, are generally confusing. So, you have to be very clear that when we talk about atomicity, it is the number of atoms present in a molecule. Nothing to do with the valency here right now, right? So, now for example, you have to remember no PlayStation, no PlayStation, okay? No is diatomic and PlayStation is polyatomic, okay? Now, what is no? N is for nitrogen. N is for nitrogen. What is the formula for nitrogen molecule? N2. O is for oxygen. What is the formula? O2. H is for hydrogen. What is the formula? H2. Okay? And last H is for halogens. Last H is for halogens. What are halogens? Group 17 elements, if you remember. What are those? Chlorine, fluorine, chlorine, bromine and iodine are the elements of group 17, right? So, how are they written? They are also diatomic. So, I2, Br2, chlorine 2, fluorine 2. Is that clear? That is the molecules of halogens. Now, remember, this is not valency, because when I talk about the valency, valency of nitrogen is 3, that of oxygen is 2, that of hydrogen is 1. Valency of these halogens are also 1, -1, right? So, when you talk about the molecules, number of atoms present in the molecule is atomicity, where valency is the combining capacity of an element, to which group it belongs to in the periodic table, how many valence shell it has, that decides the valency. Is that clear? So, atomicity, these are diatomic. When you talk about polyatomic, mein you have phosphorus, that is P4, sulfur, that is S8. So, these are two polyatomic. There is one triatomic, that is ozone. Ozone is triatomic, right? Rest, whatever you talk about, is a monoatomic element. All the metals, all the noble gases, and obviously some of the non-metals leaving these are all monoatomic. Here I am talking about atomicity only, okay? Ozone is triatomic. So, remember, it's exam time, so no PlayStation. No PlayStation, no diatomic, PlayStation polyatomic, rest all monoatomic except ozone, which is triatomic. Is this easy to understand? Now, let us talk about valency. So, let me clear the board first. I hope the concept of atomicity is clear. Next is the valency. Now when you talk about valency, valency is the combining capacity of an element. Okay, combining capacity of an element. Okay, based on the number of valencies, you have monovalent, you have divalent, you have trivalent, tetravalent, and zero valent, that is zero valency. They do not like to combine, so they have the valency 0. Now when you talk about monovalent, monovalent basically are the are those elements or those atoms which has either one electron in the outermost orbit, so they are ready to give it away and attain a noble gas configuration, or they have 7 electrons in the outermost orbit, so they can gain 1 electron and attain a stable noble gas configuration. So for having valency 1, either you should have 1 electron in the outermost orbit or 7 electrons in the outermost orbit. Is that clear? So when I say monovalent, there are again, as I said, there are 2 types, so cations and anions. Now anions I will talk about. Cations, all the metals of group 1 are monovalent, and all the non-metals of group 17, they form the cations and anions with valency 1. Like for example, sodium ion, lithium ion, potassium ion, they are the examples. Group 17, fluoride ion, chloride ion, bromide ion. There are certain radicals like OH minus, then you have you can say nitrate, NO2 minus, nitrite, NO3 minus. So these are all monovalent cations and anions. Divalent, when you see divalent cations and anions. So divalent cations and anions generally belong to group 2. Okay, let me write numbers. Group 2. Okay, like you have beryllium, magnesium, calcium, right? And anions, if you talk about the sulfur family, so sulfide, oxide, then you have sulfite T, sulfate, then you have carbonate, and so on. So many anions. Tetravalent, trivalent, you have group 13 elements. Group 13 elements like aluminium, boron, right? And cations will be phosphorus group, phosphide, IDE, phosphite and phosphate, right? Tetravalent, generally group 14. Okay, now group 14 elements, generally they have valency 4. They can neither give or take electrons, so they don't form ions as such, right? So they have valency 4, like carbon and silicon, they share. Okay, so now here group 1 cations I wrote, right? Similarly, if I ask you about the metals, write it without the charge, like sodium, lithium, potassium. Without the charge, it forms a metal, it is a metal. With the charge, it is a cation. So always remember, this is important when you make the formula, right? Zero valency is all noble gases. Noble gases, what are those? Helium, neon, argon, krypton, xenon, these are all zero valency elements. Is this clear? Any doubt? So let me clear the board. We'll make few formula, and then now we have learned about the alphabets. Now we have to make words. What is making word in chemistry? Writing the formula. So after we write the formula, we'll do 1 or 2 questions, and then we move to language of chemistry, that is balancing of equations and types of equations. Now before writing the formula, there are few things that you should know, how the things are denoted or how the things are written. For example, if I write H, okay, I write H2, I write H plus, and I write H minus, okay, and I write H2O. So all are certain things present in chemistry, correct? So what are these? Now when I say H, it is an atom of hydrogen, right? An atom of hydrogen. How do I represent it in an elemental form? H A, which is the atomic mass, that is mass number, and Z. There is a slight difference between mass number and atomic mass. Okay, mass number is number of neutrons and protons, so it will be a whole number. But when you talk about the atomic mass, it is a relative atomic mass. Like for example, if you want to buy a kg of rice, then we need that 1 kg ka weight so that you can compare the weight. Similarly, in chemistry, we compare the weight of an atom with 1 atom of hydrogen or 1/12th mass of a carbon. That gives you a relative atomic mass. The answer can be in decimals. Okay, it's not necessary it will be a whole number. But when you talk about the mass number, that is number of protons and neutrons, it has to be a whole number. So that is the difference between a mass number and atomic mass or relative atomic mass. Is that clear? Similarly, when you go to relative molecular weight, then you compare the mass number or atomic mass given to you, add it up, and you make up the entire mass of a compound. Is that clear? We'll do few questions of that sort also. Now here H is an atom of hydrogen. H2 is a molecule of hydrogen. Is a molecule of hydrogen. Now hydrogen is a specific element that is present in a, in a place where it does not fit. Group 1, in the first place, it is the lightest element sitting on the group of alkali metals. It's not a metal. Then still it is sitting there. So sometimes it behaves as alkali metals, sometimes it behaves as halogens, right? So it has some, it's a notorious guy in the periodic table. Is that understood? So now when I say H plus, for writing any cation name, you have to write the name of the element, that is hydrogen, and you have to add a word ion. It's a positively charged particle, hydrogen ion. When you have a negative ion, generally we write hydride, IDE is added. Okay, it's an elemental ion, so hydride. You have radicals, there we have different words to add. But if it is a negative ion formed from the element, we have the name as hydride. You can see the example. If it is fluoride, right, F minus, nitride, N3 minus, then you have oxide, O2 minus, right. You can see all ides. Right. So it is only in the radical case, that is when you have group of atoms with a common charge, then only we have different words added, otherwise its IDE is added. Is this clear? Similarly, phosphide, P3 minus, then you have sulfide, all IDE, S2 minus, right. So negative ions are generally denoted as IDE. And positive ions, name of the element plus ion. Sodium ion, magnesium ion, aluminium ion, calcium ion, lithium ion, boron ion, beryllium ion. So that tells you it's a positive ion. Is that clear? This one, you know that it's a symbol of element. Now this one is a molecule of water. Is a molecule of water. Now you cannot change the formula of a molecule. Like one molecule of water will have one atom of oxygen and two atoms of hydrogen. If by any chance you need to give out two atoms of oxygen, you have to make the molecule 2. So if you make it 2, it becomes 2 molecules of water. You cannot add any number here. No, you'll change the formula. That is wrong. Is this understood? So let us make few formula. Now making up a formula. After this, I'll not make much. You need to solve on your own. We'll have a list of anions and we'll have a list of cations. Cations I'll take 3 so that you'll have no issues of valency. Sodium, magnesium and aluminium. Similarly, anions also I'll take, like first one I can take as chloride, that is Cl minus, oxide, that is O2 minus, and phosphide, that is P3 minus. Okay. Now when you have to make the formula, first remember you have to know the valency of each element which is a part of it. Now when I have to make sodium chloride, NaCl, valency 1, valency 1. This valency should be written here and this valency should be written here. So my formula becomes Na1Cl1. 1, 1 we don't write. So my formula is NaCl. Similarly, when you have to write for oxide, so Na and O, Na valency 1, oxygen valency 2. So 2 with this and 1 with this. So my formula is Na2O1, 1 we don't write. So my formula is Na2O. Similarly, phosphide, Na and P, Na1, P3. So 3 will be written here and 1 will be written here. So the formula becomes Na3P. Understood? Similarly, for magnesium, MgCl, Cl valency 1, magnesium valency 2, MgO, Mg valency 2, magnesium valency 2, 2, 2, we don't have to write, simplify, 1:1. So my MgO, not OMG, MgO. Then next you have magnesium and phosphide, magnesium phosphide, the phosphorus valency 3, magnesium valency 2. So this is the formula. Similarly, when you go to aluminium, aluminium chlorine, chlorine valency 1, aluminum valency 3, Al3. Aluminium and oxygen, oxygen valency 2, aluminum valency 3, crisscross method. And last, Al, P, 3 and 3, 3, 3 cancel. So write only ALP. Understood? This is how we make the formula. Any doubt? No? Any doubt? Put it in the comment section. You can go and practice other questions also. Just write the name of the compound, close the book, write the formula and then go on checking. The more you practice, the better you become in writing the formula. Is this clear? Yes. Yes. Now based on valency, many questions can be asked, right? A simple question I can tell you is like, if an element X, okay, forms a compound X2O3. Okay, I don't want what is X. Okay, what is X I don't want. I just want you to understand this, that how the valence formula has come. Okay, you have to write the formula of the compounds, write the formula of its chloride. Then you can have sulfide, sulfite, sulfate, nitrite, D. Then nitrite, nitrate, then phosphide, phosphite, phosphate, hydroxide, right. Then I can give you some more, but just pause the video here, write down the answers and then again start, so that you can check yourself how many answers you have done it correctly, or how many formula you have made correctly. So to pause the video now. I hope you have followed the instruction. Now let us check how many marks you have got. Now when my question is X2 and O3, you know that oxygen ka valency is 2, so it's written with X. So valency of X is written with O. So here in this case we could find out that valency of X is equal to 3. Now using this concept we have to write chloride, X Cl, Cl valency 1, X valency 3, X S, X valency 3, sulfide valency 2, X SO3, SO3 is a radical with -2 charge. So put it in the bracket, give the valency of X, iska valency 2. Similarly X2 SO4 whole thrice. Remember this 3 and 4 are the integral part of the radical, that is not the valency, it is only the charge which has to be exchanged, not the number of atoms. You cannot change SO, right. So here 4 is a part of sulfate, SO4 is the formula, S and 4 oxygen, SO4 with -2 charge, so -2 becomes the valency. Nitride 3 and N also 3, so Xn. Nitrite X NO2 whole thrice, X NO3 whole thrice, XP, X PO3, X PO4. Why? Because phosphide and phosphate valency is 3. Okay. Hydroxide X OH whole thrice. Now remember children, there are 3 groups, okay, 1, 2 and 3. Nitrogen family 1, sulfur family 2, phosphorus family 3. But the head of the family of nitrogen does not follow the rule. So only nitride has valency 3, nitrite and nitrate has valency 1, they follow the rule. Sulfur family sulfide, sulfate is -2. Phosphide, phosphate -3. All the bis, bisulfate, bicarbonate -1. This is just a trick to remember, okay. So this is what you can do it. There are many other radicals. You can just go to the video atomicity and valency. In the description you have the valency chart. You can go through the valency chart. Is this clear? Let me rub the board now. Now when we have seen that how the formula is being made, you can classify the elements basically as acid, base and salt, right. Now what is an acid? HX is an acid where X is equal to any anion except OH. Example, HCl, HBr, HI, HNO3, H2SO4, H2SO3, right. These are all acids. H3PO4, these are all acids. What are bases? basis is YOH, where Y is any cation except H plus. Example, NaOH, MgOH, 2, AlOH3, NH4OH, then you can have CuOH whole 2, right? Another thing like salt. When this acid and this base, anything, when an acid reacts with base, the H and the OH forms water and a salt. This is a salt. Okay, so salt has cations anything except H, anion anything except OH, that is a salt. Okay, example, you have NaCl, then MgBr whole twice, then you can have aluminium nitrate, KCl. Okay, these are the examples. So this is your acid, base and salt. Clear? Yes. This much, this if you have understood in making formula and all. Now little bit of atomic structure, that is, atoms generally comprises of two components. You have the orbits or the valence shell and you have the nucleus. Okay, nucleus contains two things, that is neutrons and protons. Together they are called nucleons and they form the, what to say, mass number. Total is mass number denoted by A. Okay, an orbit, even only the number of protons if you talk about, that is the atomic number denoted by Z. So Z minus A atomic number Z. So atomic mass minus atomic number is equal to the number of neutrons. This is important because atomic structure we are going to draw. Orbits, if you talk about, there are 4 shells, K, L, M and N shells. The N value, that is the number of shell, is 1, 2, 3 and 4. And when you talk about the capacity, there is a Borsbury rule according to which you calculate the capacity by 2n square. So K has the capacity of 2 electrons, L has the capacity of 8 electrons, it has 18 electrons and it has 32 electrons. But when we are studying about the first 20 elements, we are not filling 18 but we are filling only 8 electrons in the M shell. So now when you have to draw the atomic structure, you have to draw the nucleus. I will make the atomic structure of calcium, 20 and 40. Okay. So now atomic structure of calcium, 40 minus 20 is number of neutrons. This one is the atomic number which is equal to number of proton which is equal to number of electron. This 40 is atomic mass, that is N plus P, right. So in there are 20 protons and 40 minus 20, there are 20 neutrons. So when you talk about the shells now, So you have the K shell, you have L shell, you have M shell, and you have the N shell. Okay. Now you have to divide the electrons to each shell depending upon their capacities. Now since calcium has got atomic number 20, it has got 20 electrons. First shell K has a capacity of 2. So I have made 2 electrons here. Okay, you can make it 2 here or you can make 2 in the opposite direction, that's fine. Then L shell has the capacity of 8. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 done. 2 plus 8, 10. Now 10 is still pending. So M shell will have again 8. So this is 8 electrons, count. 10 plus 8, 18. So how many is remaining? 2. So that 2 will go into the last shell. This is how the atomic structure or the orbital structure is drawn. See to it that your electrons are solid dots, not a hollow circle, and you write the nucleus. Is that clear? Now forming of ions and all, we'll do it later. It's or if you want, no. Now for forming of ions, the last shell loses the electron. So if calcium has to form an ion, calcium will lose the last 2 electrons to form calcium ion, correct? Now with the last 2 shells, that is the electrons from the last shell has to be lost, then the last cell stops to exist. Okay, now what happens? If there is no last shell here in the calcium, what happens? Now this calcium has got minus 2 electrons, that is total electron becomes 18, but the number of proton is 20. There are 2 protons extra, 2 positive charge extra. So this forms the calcium ion with 2 positive charge. So remember, whenever you are writing the electronic configuration or orbital structure, atomic structure for an ion, you have to put it in the square bracket and put a charge to it. Without the charge, it is not an ion. So you will not secure your marks if you don't write the charge in case of ions. In case of normal element, there is no need of the bracket and the charge. Is this understood? Yes. Is this understood? Now let me clear the board. Now we have understood about how to write the symbols, then how to make the formula, then how to write the formula by exchanging the valencies. So alphabet word is done. Now next is making a sentence, that is writing a chemical equation and then balancing the chemical equation. Now there is a law called law of conservation of mass given by Lavoisier. According to him, the mass of the reactant should be equal to the mass of product, and this rule has to be followed. That is why the unbalanced reactions do not even exist. We have to balance the reaction so that the mass of the reactant equals to the mass of product. Right? How you calculate the mass first? Like for example, if you have a compound called calcium carbonate, you have to identify each atom, calculate its mass. Now this mass is 40, carbon is 12, oxygen is 16 into 3, that is 48. Add all of them together. So what is this? 48 plus 12 is 60 plus 40 is 100. AMU, atomic mass unit. This is how we calculate, and this should be equivalent on the reactant side and the product side. So let us see how to balance the reaction. Now while balancing the reaction, we will also study the conditions or how you come to know that a chemical reaction has taken place. Now chemical reaction, like for example, if there is evolution of gas, or there is change of color of the salt, or there is some precipitate formation. That is how we find out that the chemical reaction has taken place. So, we will do few reactions, is that okay, and at the same time we will keep balancing the equations, fine. Now, the first condition how we come to know that the reaction has taken place is change in color, change in color, okay. Now, the first example that I will take is copper carbonate, copper carbonate, okay. This is copper carbonate. When it is heated strongly, you have the formation of copper oxide plus carbon dioxide, okay. Now, copper oxide, that is, now here the valency of copper is 2. So, copper 2 oxide, I hope you know this concept, right, copper 2 oxide, and this is carbon dioxide. This arrow tells you that the gas is released, okay. Now, the color of copper carbonate, the color of copper carbonate is green, okay, it is green in color. When it is heated strongly, it is decomposing, right, it is breaking down into simple compounds. If it is heated strongly, it turns into a black residue. Now, there is a difference between the words, I will tell you. Residue is something left over. When you are heating this solid, green color salt, on heating it decomposes, matlab it breaks down into black residue and the gas is released. So, this example can also be a change in color and evolution of gas, is that okay? Now, when carbon dioxide gas is released, you can see here the name the gas released, it is carbon dioxide. And what is the color change from green to black? Similarly, next reaction is zinc carbonate, okay, zinc carbonate, that is your zinc carbonate. It is a white color salt, okay. When it is heated strongly, you have the formation of zinc oxide, okay. This is zinc oxide. Now, zinc oxide is yellow when hot, and when you allow it to cool, it turns white, okay. This changing in color from yellow to white is a physical change, but formation of zinc oxide from zinc carbonate is a chemical change, and here also the gas evolved is carbon dioxide, right. Similarly, you have one is lead nitrate. I am not writing the name, children, you can make a note of it. Lead nitrate, when it is heated strongly, you have the formation of lead oxide plus nitrogen oxide plus oxygen gas. Now, here if you this is the reaction. So, this one is also a yellow residue, but what is the difference between a lead residue and a zinc residue? Zinc oxide is yellow when hot and it cools down, it becomes white, but lead oxide remains yellow, it does not change. This is how you differentiate between these two. Is that clear? Now, see the reactions, okay. The reactions are written, law of conservation of mass we are going to check. Here copper is 1, here copper is 1, carbon is 1, carbon is 1, oxygen is 3. So, here also 1 plus 2, 3. So, this reaction is a balanced reaction. So, according to the law of conservation of mass, the mass of the reactant is equal to the mass of product, because number of atoms are same. So, we need not calculate it all the time. So, here we just have to make the number of atoms equivalent on both the sides. Here also if you see, zinc is 1, zinc is 1, carbon is 1, carbon is 1, oxygen is 3, 1 plus 2, that is 3. Problem will happen here and I will tell you how to balance it, right. Now, here lead is 1, lead is 1. How many oxygen it has? 3 into 2, 6. So, I will write this reaction. Let me clear the board first. The lead nitrate was heated strongly to form lead oxide plus NO2 plus oxygen. Okay. Now first thing that you have to do is write the atoms present in the reactant side and then write the atoms present on the product side. The number should be same. So here lead is there, nitrogen is there and oxygen is there. And here lead is there, nitrogen is there and oxygen is there. Correct? Now when you talk about lead, lead is 1, nitrogen how many? It's whole bracket, right? So nitrogen is 1 into 2, that is 2. Oxygen is 3 into 2, 6. Understood? Here product side lead is 1, oxygen, nitrogen is also 1, oxygen is 1 in the first, 2 in the second and 2 in the third, total it is 5. Is that clear? Now here is 6, here is 5. If this 1 becomes 2, I will have balanced oxygen. So let me use another chalk piece. Now I will make the molecules 2. So what happened? This oxygen has become 2, but my lead also became 2. Correct? So now my oxygen is 6. So my oxygen ka concept is balanced. Now to make this lead 2, I have to multiply 2 here. For this I need to multiply 2 here. Correct? Now for doing this, what happened? This got multiplied, this got multiplied, this got multiplied. So here you have 2, here you have 4 and here you have 12. My oxygen also is not balanced now. Third step, what I will do, I will check. Now lead is balanced, my lead is balanced. Nitrogen is 4 and nitrogen is 1. So we will talk about oxygen later. Let us balance nitrogen first. 4 and 1. So if I write 4 here, my nitrogen becomes 4. That is, my nitrogen becomes balanced. But as I wrote 4 here, this also gets multiplied. So this becomes into 4. So 2 plus 4 to the 8. 8 plus 2, 10 plus 2, 12. So this becomes 12. Now automatically my oxygen got balanced. Correct? So what I have done, I have just maintained the number of reactants and maintained the number of products, atoms in the reactants and the products. So now my complete reaction is this. Is this clear? Let us take some few simple examples. Okay, this was little complex, but I hope you understood. Now let me take some simple ones. Next we will take an example of evolution of gas. Let us see evolution of gas and we will learn about the balancing also. Evolution of gas. Now the simple example, KClO3, this is potassium chlorate. When it is decomposed, it forms KCl plus O2. Okay. My reactants and my products. There is only one reactant, it is a decomposition reaction, only one reactant. What atoms it has? It has K, it has Cl and it has O. Similarly, it also has K, Cl and O. 1, 1 and 3, 1, 1 and 2. Now let us see oxygen, because oxygen is the only atom which is not balanced. So for making 3 and 2 come to a same number, LCM is 6. So we have to multiply 3 here and 2 here. If I multiply 2 here, my this becomes 2, my this chlorine also becomes 2, and if I multiply 3 here, nothing happens, right? So now my now my potassium and chlorine is not balanced. So for that I have to multiply 2 and 2 to make it 2, 2 and 6. So 2, 2 and 6. Now you can see now you can see K, Cl, O all are balanced. Understood balancing? And here which is the gas released? Oxygen gas is released. Clear? Evolution of gas. Let us take few more examples. Zinc plus HCl. This is a metal plus acid mash reaction. metal plus acid gives salt and hydrogen. It's not a type of reaction, it's just a mnemonic to remember. MASH, metal plus acid gives salt and hydrogen. So zinc plus HCl gives you zinc chloride, zinc valency 2, chloride valency 1, ZnCl2 plus H2 because H is a diatomic gas, right? Now we have to balance it. Zinc is 1 and 1, hydrogen is 2, so hydrogen we have to balance, and as I balance HCl, my reaction is balanced. Is that clear? Next we can talk about next reaction is NaCl plus H2SO4. Okay. Now this will give rise to, this is a salt, this is an acid. So exchange this one with this and this one with this. Do not miss with the valency, okay. You just know the elements. Now here sodium sulfate, sodium sulfate, sulfate valency 2, okay, and hydrogen chloride, hydrogen 1 valency, chlorine 1 valency, HCl. This is a gas here, hydrogen chloride gas, okay, and it's a salt. So here HCl is a gas released. It will give white dense fume with ammonia. We will study about the test of the gases later, but if you understand this much is more than enough. In the next video of the basic concepts, we talk about the test related to the gases, okay. Now this video we are just focusing on the basic concepts. Now next one, another gas that can be evolved is carbonates, like calcium carbonate. If you treat with HCl, an acid, any carbonate treated with acid will give you carbon dioxide. Any metal treated with acid will give you hydrogen, except few least reactive metals. And here what is the outcome? Calcium chloride. So calcium chloride valency 2, calcium chloride, and HCO3. HCO3 will form H2CO3. Now remember, whenever H2CO3 is formed in the product, it decomposes to give you H2O and CO2. Understood? So here what will be my reaction? I will not write this, okay. I will write plus H2O plus CO2. This is the gas released. Is that clear? Now if you have to balance it, calcium 1, chlorine is 1 and chlorine is 2 here. So let me write chlorine 2, hydrogen is now 2 here, hydrogen is 2 here, oxygen is 3 and oxygen is 1 plus 2, 3. So it's a balanced reaction, okay. All the arrows tell you that it's a gas released. Next reaction, let us take sodium sulfite, Na2SO3, when you treat with HCl. Now here Na and Cl will form sodium chloride, HSO3 will form a compound called H2SO3, and this will break down into H2O and SO2. Remember this, okay. So what will be the outcome here? My reaction, it will be NaCl plus H2O plus SO2, okay. Now Na2 hai, so you have to balance it. This is 2 and this is 2. This is your balanced chemical equation. Understood? And this is also an example of evolution of gases. Is that understood? Now next one is the formation of precipitate. Formation of precipitate. Now precipitate is insoluble salt. Insoluble salt formed in solution. So the important criteria for the formation of precipitate is the solution. The reactant should be in solution form. Let us take the first example. Like if you take copper sulfate in NaOH, okay, you have the formation of copper hydroxide and sodium sulfate. Now always remember, sodium and potassium salts are soluble in water, so they will never form precipitates. Whatever is not a sodium and potassium salts, they will form the precipitate, right. So now here this is a sodium salt, so this will be soluble. This one is a precipitate. For gas we give an upward arrow, for precipitate we give a downward arrow, and the color of this precipitate is pale blue precipitate, okay. Then next you have balancing. Is all balanced? No, sodium is not balanced here. So sodium and hydroxide, this is now a balanced reaction, okay. Next one is you can have iron Fe ferrous sulfate, FeSO4 plus NaOH, okay. It can be NaOH, it can be KOH, it can be NH4OH, it can be any base, okay. Any base means what to say, strong base. NH4OH can also be used, okay. So here what is the thing formed? Fe, valency is 2 here, so FeOH whole twice, it is a precipitate, and sodium sulfate is a soluble salt because it is a salt of sodium. Now FeOH whole twice, this is a ferrous iron, so it will be a dirty green precipitate. You have to know the color, children, dirty green precipitate, okay. Similarly, you talk about FeCl3 plus NaOH, it will give you ferric hydroxide, it will be a precipitate, it will be reddish brown precipitate, reddish brown precipitate plus NaCl3, okay. This is reddish brown precipitate. Similarly, zinc hydroxide, gelatinous precipitate, calcium milky white precipitate, and lead will give you chalky precipitate, a chalky white precipitate. How you remember? Gelatinous, zinc, just to sound similar, zinc, gelatinous, chalky white, lead, you write with lead, it is not the same lead, I know, but you write just to remember chalky white precipitate. Calcium is for the bones, strong bones, milk, so milky white precipitate. Is that clear? So this is how we understand that if something insoluble is being formed. So you need to know the color of the precipitate and the ions. Like generally these reactions are used for cation analysis, which metal is present. So copper, pale blue precipitate, that is Cu2 plus ion, Fe2 plus ion, dirty green precipitate, Fe3 plus ion, reddish brown precipitate, Zn2 plus ion, gelatinous white precipitate, Pb2 plus ion, it's chalky white precipitate, calcium 2 plus ion is milky white precipitate, and so on and so forth. Understood? This is the formation of precipitate. Now there are certain reactions in which light, heat, energy and all is required, okay. So now for the reactions in which heat is absorbed, taken in, like decomposition reactions where you have all the breakdowns we have seen, there we need heat energy. So heat is absorbed to break the bond, that is called endothermic reaction. If large amount of heat is released, it is called exothermic reaction. Some reactions require catalyst. What is a catalyst? A catalyst is a substance which itself does not participate in the reaction, but it may increase or decrease the rate of reaction. If a catalyst increases the rate of reaction, it is called a positive catalyst, and if it decreases the rate of reaction, it is called a negative catalyst. For example, we saw a reaction KClO3. Now decomposition of potassium chlorate, if you add little bit of manganese oxide MnO2, it behaves as a positive catalyst. It increases the rate of decomposition of potassium chlorate. If you take phosphoric acid and put it to hydrogen peroxide will not dissociate into water and oxygen. So, this phosphoric acid inhibits the decomposition reaction of H2O2, so it becomes a negative catalyst. Understood? Now, there are certain elements like certain terms like promoters, inhibitors. These are the accessories of the catalyst. If you take a molecule which increases the efficiency of the catalyst is a promoter, which decreases the efficiency of the catalyst is an inhibitor. Understood the concept of catalyst? Then there are certain reactions like electrolysis of water. Electrolysis of water, if I say H2O gives rise to H2 plus O2, okay, in the presence of electricity. Now, you can see here one atom of oxygen and 2, so I have to balance it. Now, this reaction, okay, is the electrolysis of water. If you want a video just to explain electrolysis to you, put it in the comment section. I will go in detail of electrolysis in the next video if you need it. Okay, now what happens, electrolysis of water, whenever 2 molecules of water is broken, 2 is decomposed, 2 molecules of hydrogen and 1 molecule of oxygen is released. Okay, this is electrolysis, passing electricity. So, electricity is a form of energy, so it is decomposition reaction. Similarly, light related reaction, photosynthesis is a very good example where light is needed. Then you have seen certain chemicals kept in your laboratory in the brown bottles, because they are light sensitive. Okay. So, when the light will like silver bromide is stored in a brown bottle, because silver bromide is very sensitive to light. As light falls on it, it dissociates into silver and bromine. So, obviously the compound is lost, right. So, that is light dependent reactions, heat dependent reactions, catalyst dependent reactions, right. Go through all the reactions in your textbook. See to it that you know how to balance the reactions. Then use your common sense. Like if you talk about electron, protons and neutrons, what are you exactly talking about? How to calculate the number of electrons, protons and neutrons if you know the atomic mass, atomic number, how to draw the electronic structure diagram. All these things are very important. I hope I have tried to cover almost all the topics in this video. Any other doubt, put it in the comment section. If possible, we will make the video soon. Yes, thank you children, happy learning.